Hello everyone, this is a practical study for configuring a Linux box. Actually, it's running Fedora 31 to act as router and firewall device for controlling the network packets between private LAN, DMZ network and the internet. As you see here in the diagram, we need to let our client on the private LAN to be able to access the internet as well as to access the services on our DMZ network. Also, the DMZ services should be available for public access from the internet. Here I'm going to use IPTables for that, and the Linux box should have 3 configured network interfaces cards, one connected to the private LAN and second one is connected to the DMZ network. The last one is connected to the internet with public IP address assigned to it through a DSL device. To save time, I'm not going to discuss or explain the basics of the IP table in detail here, but you will find a lot of information and documentation about the topic out there on the internet, so you have to Google for that. Let's go directly to the point. The IP packets coming to the Linux box will pass through the IP table chains as shown here in the figure. You can forget about the row and mangle table in this scenario. So after passing through the pre-routing chains in the row and mangle table, it will arrive at the net pre-routing chain, and here where we will do some denetting to our DMZ services. Then after that, the routing decision is taken, and if the packet is destined to the Linux box itself, it will be passed to the mangle and filter table input chain, as you may see here, then to finally to the local process. But if the packet is destined to somewhere else, it will be passed to the forward chains in the mangle and filter table respectively. Then the post-routing chains in the mangle and net tables, and finally sent out to its destination. The right part of the diagram show how the packet processed when generated from local process web browser, for example, running on the machine itself. Okay, let's now start configuring this Linux device to act as router and firewall for the connected networks. Here are the steps that should be taken for that. First, we need to make sure the following packages are already installed on your system. If not, go and install it. You can use DNF for that. DNF install IPtable devel, IPtable utils, services, xtable added on, akmod xtables added on. Just install these packages, and it's already installed on my system. Next, we need to disable and mask firewall D and stop it, of course. System ctl stop firewall D and disable it and mask it. Okay. Then we need to start enable, but before that we have to unmask. If it is masked, it will not start. Systemctl unmask IPTables. Okay. Start it, enable it, okay. First and before doing anything, we have to make a backup copy for the original configuration file for the IP table. For that, we can use IPTables save conf. Okay. Next we need to flush all the rules in the filter table. Flush. Okay. Then set the policies for the filter table input chain to drop. Policy for input drop. For the forward chain also drop, and for the output chain to accept. Okay. With respect to the net and Manjel, everything here should be accept. So the pre-routing chain in the net table the default policy for the net and Manjel should be set to accept. Output chain in the net accept. Post routing for the net should be accept. Same thing for the Manjel. We set all the policies here to accept. Input Manjel accept. Forward Manjel default policy to accept. Output chain for the Manjel to accept, and the post routing for the Manjel table should be accept. Okay. Next we have to confirm that everything is cleaned from the IP table filter and net and the Manjel. We also need to delete all custom chains from the filter table and from the net table and from the manual table. Okay, we need to reset all the packet counters from the 3 tables for the filter, for the net, and for the manual. Okay, for the IP6 tables, let's start it. IP6 tables, it is masked, so you have to unmask it first. Unmask. Okay, then start it, enable it, okay. We need also to save the original configuration file to make a backup copy from the original configuration file for the IP6 tables. Okay, IP6 tables, save. Tables, original config. Okay. Now we need to set the default policy to drop for the filter table in the IP6 tables. Okay, for the input, for the forward, and for the output, nothing will pass through this IP6 table. Okay, for manual and net, we will set all the policies to accept. IP6 tables policy. Policy. T manager. Sorry. Sorry. Yeah. Routing. Okay. Input and forward. output chain, and post routing. Okay. Now we need to flush the IP6 table filter table. Same thing with the net and the manual table. Clean all custom chains. From the filter and from the net table and from the manager table. Same thing with respect to counters, packet counters. Okay. Then we need to save this modification to be the default. Okay. Service IPTables, save, and IP6 table, save. Now let's restart services. Restart IPTables and IP6 tables. To make sure that everything is clean, we can list the contents of IPTables and IP6 tables. List and the line numbers. So as you see here, nothing is there, and the input chain policy is drop, the forward is drop, but the output is accept, and nothing there inside the table. Let's see again. Okay, this is for filter table, for net, also nothing, but all the policies is set to accept here. And for manual, also it's clean. Let's see the IP6 table. It's clean. This is the filter table and the net. It's also clean. And for IP6 table manual, also it's clean. Now we just cleared everything from IPTables and set the filter table input and forward chain policies to drop, so nothing allowed to enter or pass through the system, not even the network traffics on the loopback interface, a completely closed system. So first we need to allow traffics on the loopback interface. The following rule will do the job. IPTables added input protocol all input interface loopback source address 127.0.0.1 destination address 127.0.0.1 J accept. This rule will allow traffics, all kind of traffics on the loopback interface. Okay, if we list the input chain now, IPTables list input and v line numbers, we will find only one rule that we have just added to IPTables. Next, we need to create a custom chain to drop all invalid packets and added that to the filter table input and forward chains. Here, the first rule will create the bad custom chain. The second rule, which is added to the input chain, will pass all packets with state invalid to the bad chain. The third rule we added to forward chain. Do the same thing, pass all packet with state invalid to the bad chain. The bad chain itself consists of these rules. The first one here says that for TCP protocol, if the first packet for a connection attempt come into the system but not sync, drop it. In second rule, we inspect these TCP flags for the incoming packets, and if none of them is set, drop it. Also, with respect to the third rule, we inspect the SYN and FIN flags for a TCP packet. If both set, drop it. The same for the SYN and reset flags. If both set on a TCP packet, drop it. Next, we inspect the FIN and reset flags. If both set in a TCP packet, drop it. Then the acknowledge and FIN, if only the FIN is set in a packet, drop the packet. The last rule inspects the acknowledge and the urgent bits, and if only the urgent is set but not the acknowledge, drop the packet. These are all the most important invalid cases, I guess, for TCP protocol that should be dropped, and should be dropped as early as possible in IPTable for the sake of performance. Let's now enter these rules to the IPTables. Tables bed append to input chain for forward chain. Okay. Next, we will create a custom chain for dropping all unwanted broadcast and multicast packets, and added that to the filter input and forward chains. This rule will create the bcast chain, and the next two rules for adding them to the input and forward chains in the filter table. Here we drop all packets coming from or destined to the 224.0.0.0/4 multicast address. Also, we drop all packets coming from the 240.0.0.0/5 source address. Let's now enter these rules to the IPTables. IPTables bcast, then and the last one. Okay. And here is it. Okay. Next, we accept all established and related connections for TCP, UDP, and ICMP protocols, and these rules should be added only to the input chain. Let's now edit these rules. IPTables append input P TCP M contract state established and related J accept. The same thing for UDP protocol, UDP, and for ICMP. Okay. IPTables list input NV line numbers, and here is it. Okay, we want to allow pinging to our host from anywhere, but no more than 5 echo requests will be allowed in 2 minutes time window from any specific IP address. This is to avoid ping storm denial of service. Here we will use the IPTable recent module for that. It works by watching and tracking the connection attempts to a service from different IP addresses and create a list for that. Then if it finds too many connection attempts from some IP address within a predefined time window, it will drop any new connection attempt from that IP address for a period of time equal to the time window we just put for that. Then allow the connection again from that IP address till he or she again exceed the limit, drop it again, and so on. And this is a good strategy to stop ping storm denial of service. Also, you may need to drop the address mask, timestamp, and router solicitation ICMP types. The first rule here will create the ICMP custom chain. The second rule, which will be added to the input chain, will send any ICMP packet with state new to the ICMP custom chain. In the ICMP custom chain, we drop all the address mask request, timestamp request, and router solicitation ICMP types. Here with this rule, we create the ICMP list to track the different addresses that send us echo request and update the list every time new echo request comes to us. This rule will check the list to see how many echo requests comes in within 2 minutes from an IP address, then allow only the first five requests and drop anything exceeding that from this IP address for 2 minutes, then allow it again, and so on. The last rule here will accept the allowed 5 echo requests from the previous rule. Let's now enter this rule to IPTable. IPTables ICMP to create the custom chain for ICMP processing. Okay, then we need to IPTables append input chain protocol ICMP with state new mcontract contract with contract state state new J, send it to the ICMP custom chain. The third rule, we drop the address mask request, and this rule will drop the timestamp request, and this to drop the router solicitation type, ICMP type. This will use the recent module to create the list to track who ping us and update the list. The list name is ICMP list. Then we check the list to see how many echo request comes to us within 120 seconds or 2 minutes. J drop okay, and the last rule to allow only the first 5 hits. Okay, IPTables list input and V line numbers, and here is it, rule number 7, which will send all ICMP to this custom chain to process it. Also, we want to allow SSH to this Linux router, so we need to create another custom chain for that. Here I have some points to mention. First, I have disabled user password authentication to the SSH daemon. I only allow public private key passwordless authentication, so it's safe to open the SSH for anyone to try his luck, but of course within limited number of trails per minute. Let's now enter the rules to the IPTables. The first rule, create the SSH custom chain. The second, will send any packet destined to TCP port 22 with state new to the SSH custom chain. The third rule uses the IPTable recent module to create and update the SSH list that will be used to track connection attempts for the SSH daemon. The next rule will inspect the list to check the number of connection attempts for the SSH from any IP address. Here, if the number of connection from an IP address exceed 10 within 5-minute time frame, any new connection attempt from such address will be first logged to the system log, then drop in the next rule for 5 minutes, then allowed again and dropped again if it exceeds the limit, and so on. Okay. If we list the input chain, we will find the SSH custom chain we just created at the end of the input chain rule set. Okay. At this point, and to finish up with this part, we have to save the rules that we have had entered till now to make it persistent after restarting the service or after system reboot. Service IPTables save. Okay, thank you for watching, and to the next part.